Let's start this by doing what we were just looking at. So we're collecting like terms first. It's what we most recently did. So 3a goes with the 6a. So we get 9a. Oh, I was going to write x, 9a. And then our -7 plus 8 gives me plus 1. Okay, so that's collecting like terms. And then if we think back even further, we can simplify this by using our exponent laws. So I'll do top, bottom, and then put it all together. So let's look at our numbers first. 5 times 10 is 50. 2 plus 5 is 7, divided by 4, and then a to the 6. Well, this is going to be, well, we could do 12.5, but we'll do 25 over 2. We'll leave it as a fraction. And then there's 1a left. Okay? You could write 12.5a and I wouldn't mark it wrong. So today we're looking at distributive property as well. So to distributive property, if we did something like this, what this means is if we did this with bedmass, this first question, so we have 2, and we have to do brackets first. So we get 11, and that's 22. But if I took that 2, and I multiplied it here, and then I multiplied it here, kind of like we did in the second part. So 2 times 6 is 12, plus 2 times 5 is 10. We're going to get the same answer. Now, we would do this a lot of the times when we don't have something that we can collect like terms, like 5 and 6 you can put together. What if you have something that you can't? That's when we do the distributive property. We multiply that 2 into each part of the bracket. So if we're looking at something like this, so before you start, you always want to do brackets. So can you simplify the brackets? Then is there any exponents? Well, now we need to multiply. In this case, there's no exponents, so what we're going to do is we're going to do 3 times 2x. Okay, so 3 times 2x is 6x. And you're going to see that I'm going to try to draw an arrow every time so that it kind of drills into your head. Then we do 3 times 5. Well, 3 times 5 is 15. As long as I've collected like terms at the start, I shouldn't have to do any collecting like terms at the end because it should already be simplified. Sometimes if there's more than one bracket we're putting together, then we have to do some collecting like terms. But as long as I'm just distributing into one bracket, it should already be done for me. So if we look at this next one, we can do it the same way. Okay, normally that 4 would be written in front, kind of like the next two examples. But if you think about it, that 4 can go to the 6y. So that's 24y. And then that 4 can go to the -5 minus 20. All right, the next question, we always have to look at the positives and negatives. Remember, 2 positives is a positive and a negative is a negative and a positive is a negative, and 2 negatives is a positive. Okay, so here we're doing -3 times 5m. -3 times 5 is -15, and then we have our m. -3 times -2n is going to be -3 times -2, which is positive 6n. All right, now we're getting into some variables, but the question applies in the exact same way. I'm going to multiply that x here. The x doesn't do anything to the 2, so the 2 just stays there. But if I have an x times an x, that gives me x squared, because 1 plus 1 is 2. Then I'm going to multiply the x times 6. Well, it doesn't do anything to the 6, and I'm going to have 1x, so I just have 6x. Okay, you could write that 1, but you don't have to. All right, so now even a little bit harder, a number and a variable. Well, that number goes with the number. 3 times 2 is 6, and the variable goes with the variable, w squared. Over here, number goes with the number. 3 times 5 is 15. The variable goes, well, by itself because there was no other variable. I guess a little bit harder. Still not that hard, though. 3 times 2 is 6. And then we just do exponent laws. Okay, that's why we did it on that first slide. Okay, so g squared times g cubed, we're adding exponents. G to the 5 plus, we've got 3 times 5 is 15. G squared times G is G cubed. Okay, now this one, even though it looks a little harder, it's not any harder, it's just longer. I guess I'll zoom out here. So -4 times -1 is going to be +4. Then x times x squared is x cubed, because that x has a 1 on its exponent. The next part, we're doing -4 times 5. Well, that's -20. Then x times x is x squared. Last, we're doing -4 times -8. So we're getting +32, and then we have to put our x in. With the x's, you're just kind of thinking about how many x's do I have? Well, I had 1 at the start, and then in the first term, I'm multiplying it by 2 more. The first one has 1. The second term, I'm multiplying it by 1 more, so I have 2. And the last term, I had none, so I'm just getting 1 from that first multiplying. Here, if we look at this, we've got this last example here, so I'm just going to move it down so we can see it a little better. This one's a little harder, but it's actually not too bad. Look at all the numbers first. So -2 times 3. Well, that's -6. Now I'm going to look at the x's. X cubed times x squared. Well, that means there's 5 x's there. Then I'm going to look at the y's. Y to the 4 times y. Well, that's 5 y's. Now I'm done that part. Now I need to do the same thing to the next term. So -2 times 6. Well, that's -12. Then x cubed times x to the 5. Well, that's x to the 8. And then y to the 4 just goes in there because there's no other y's. Okay, your questions are on 166, numbers 1, 3 to 7. You're just doing the left column for numbers 3 through 7, and 11.